All right, we're going to apply the Cauchy integral formula again to compute this contour integral. So C here is the circle of radius 4 centered at 2I. So if we were to draw C, it's always helpful, always draw the picture if you can. Ooh, I need to put it down a little bit more. So let's see here, 2I, 1, 2 is 2I, and the radius 4, so I got to go up 4, I got to go over 4, and 1, 2, 3, 4, down 4. Okay, so C is the circle here, goes through these points. And we're computing the contour integral over that circle of the function z over z squared plus 9. Now this function z over z squared plus 9, let's see, z squared plus 9, it looks like is 0 within this contour. We can factor z squared plus 9 as z plus 3i, z minus 3i. And z equals 3i is therefore a 0. That's up here. This is 3i. But we seem to avoid the other one. The other one's down here at negative 3i. So we can take the z plus 3i and sort of push it into the numerator of our function. So we can instead look at like z over z plus 3i all over z minus 3i. The big slash meaning the outside fraction has denominator z minus 3i. Okay, so f, if we were to set f to be z over z plus 3i, this is analytic on a domain, on a simply connected domain, containing the singularity z equals 3i. Okay, and what is that simply connected domain? Well, you could use a bunch of things. Z over z plus 3i only has an issue when you plug in negative 3i, so you could use the domain imaginary part of z bigger than negative 3. So that would be the upper half plane with a cutoff at negative 3. All right, so the function f has no problems in sort of on and near C and also interior to C. The z minus 3i does though. So we are in a situation then when we can apply the Cauchy integral formula. So by the Cauchy integral formula, the value of this contour integral is really, of course, the value of the integral of z over z plus 3i, all divided by z minus 3i. And that's going to be 2 pi I times the value of our function at what's our singular point? It's 3i. So I've moved the 2 pi I over. So that's going to be 2 pi I times f of 3i, which is 3i over 3i plus 3i, which is what? 2 pi I times 3i over 6i, which is a half. So we get pi I. If I did everything correctly. I make mistakes, but seems right. So this problem, it didn't appear like we could use the Cauchy integral formula, but nevertheless we could. And so hopefully we're starting to see the utility of this formula. It's fantastic, right? Like we didn't have to parameterize anything. We didn't have to rely on partial fractions. We just said, hey, here's our function. It's analytic where we need it to be. The value of the contour integral is the value of the function times 2 pi I, and we just got to plug something into a function.